Welcome to The Explainer. Today we're diving into the absolute ultimate architectural blueprint for software engineering, linear data structures. If you've ever found yourself wondering how complex data is organized, processed efficiently right under the hood of your favorite apps, well, you are exactly in the right place. We're going to treat these data structures not just as some abstract theories, but as the literal, fundamental building blocks you need for digital construction.
So let's define exactly what we're building today. A linear data structure is essentially your foundational framework for organizing data. And our core objective for this explainer is pretty straightforward. We want to truly know linear data structures and be able to interpret all linear data and functions. The absolutely crucial point here is that we're not just memorizing textbook definitions, right? We're gaining the actual ability to manipulate the very framework of data itself.
Okay, let's dive into this. Here's our masterclass agenda so you know exactly how we'll progress from theory to application. 1. The linear data foundation. 2. Mastering arrays and stacks. 3. Exploring advanced queues. 4. Linking the list together. And 5. Real-world engineering outcomes.
Starting right off with Section 1, the linear data foundation. Every great structure relies on really strong pillars. And in linear data management, those core pillars are arrays, stacks, queues, and linked lists. I want you to think of these as the essential tools in your engineering toolkit. Each one handles data in a specific, linear sequence. But, and this is a big but, the rules for how they actually store, access, and release that data vastly different. Honestly, knowing how to choose the right one for the job is exactly what separates a good engineer from a truly great one.
Moving right along to Section 2, Mastering Arrays and Stacks.
So, the array. This is your baseline structure, literally the most straightforward representation of linear data we have. But looking beyond just standard arrays, we really need to wrap our heads around the sparse matrix representation. Imagine, if you will, a massive spreadsheet where 90% of the cells are completely empty, just zeros. Storing every single one of those empty cells in a standard array, that's just throwing away valuable memory. A sparse matrix solves this brilliantly by only recording the actual data points, which allows you to be highly efficient with your digital real estate.
Now, stepping from that baseline over to the stack, we enter the world of strictly sequential operations. And this brilliantly illustrates how stacks operate on a last-in, first-out, or LIFO principle. You're going to use them for things like parsing Polish and reverse Polish expressions, compiling code, and executing recursion. Just picture the famous Tower of Hanoi puzzle, right? You can only move the rings by taking the top one off the pile first. All of these applications basically share that exact same common thread. Your data must be stacked up and resolved strictly from the top down.
Which brings us to Section 3, exploring advanced queues.
Okay, so if stacks pile things up, queues are all about managing lines of motion using a first-in, first-out, or FIFO flow. Standard queues, they just handle data waiting in line. But the variations, that's where things get fascinating. Take a circular queue, it literally connects the end right back to the beginning for continuous processing. Then you have the double-ended queue, which lets data flow in or out from both sides. And a priority queue, well, it dictates flow not by who arrived first, but by the specific importance of the data itself. And fun fact, it actually often utilizes our baseline array structure under the hood for its representation. Next up, Section 4, linking the lists together.
So, linked lists. These show us how data points can be logically chained together rather than just being stuffed side by side into fixed memory slots. We've got the singly linked list going in one direction, the doubly linked list traversing back and forth, and the circular linked list forming a completely closed loop. But honestly, the real ingenuity kicks in when we start combining these concepts. We can actually use these dynamic chains for the linked implementation of the stacks and queues we were just talking about. By applying strict sequential rules to a highly flexible chain, you unlock some incredibly adaptable memory management.
And finally, Section 5, Real-World Engineering Outcomes.
I really want to pose a direct question to you right now. How do these fundamental mechanisms actually solve real-world problems? I mean, the theory is great, but as focused learners, we're here for the real-world results. So let's take a look at how you'll take these exact concepts and apply them to achieve specific engineering standards.
When we map these concepts directly to engineering benchmarks, a really clear path emerges. Foundational outcomes require you to apply linear data management to solve actual problems, like tying outcome 2.2 to its specific engineering code, PI 141.1, by using a stack structure to evaluate a complex bottleneck. But it goes deeper than that. You absolutely must be able to identify existing methods and, crucially, their limitations. You need to know exactly where standard data structures work perfectly and where they'll completely break down under real-world pressures. Now, at an advanced level, it is all about integration. You're expected to implement and integrate modules across several applications by fully leveraging these mechanisms, linking directly to those advanced P-codes. This means taking everything from arrays all the way to circular queues and actually designing custom methodologies. And this right here is the ultimate takeaway. You aren't just learning what lists are, you're literally learning how to design the architecture that powers modern data collection and analysis.
To reach that elite level of system design, there's a master challenge you've got to tackle. To truly master this blueprint, you need to independently explore those hybrid implementations we touched on today. I challenge you to dive deep into the linked list variations of stacks and queues and really unravel the intricacies of circular, double-ended, and priority queues on your own time. These advanced structures, they are the absolute secret weapons in a top-tier engineer's toolkit.
Which leaves us with this final provocative thought. Based on everything we've unpacked today, from baseline arrays to advanced, hybridized queues, will you simply use standard data structures, or will you identify their limitations to engineer a vastly better solution? The blueprint has been completely laid out for you. Now it's time to go out there and build something incredible. Thank you so much for joining me for this explainer, and I can't wait to explore more fascinating topics with you next time.